All right, so welcome everyone. We've got about 90 minutes, so I just wanted to make sure that we get going and not waste any time. So what we will cover today is the design question. If you're not on the Mozilla Etherpad, please make sure that you log into that. The link has been posted on the meetup, and it's also on the free conference call wall. And if you don't have a link to the blog, find it on the meetup as well. Get there. If you're not on the audio conference bridge, you cannot hear me speak, so I can't do much there. But please make sure that you're dialed into the audio bridge as well in the future so that you can listen to the conversations. All right, so moving on, today the focus will be the design question first, and what we will do is we'll take a little bit of a step back and kind of cover the older question and solve it. So the idea here is that you're trying to find, you're trying to design a meeting scheduling system where you're given a meeting of a duration, which will be like in 30-minute increments, and you're looking at participants. Let's start with the case where every participant is mandatory. You know their availability in 30-minute chunks for the next 7 days, and your goal is actually to find out a slot where all the participants are available for that duration. So if it's a 1.5-hour meeting, you need to find a 90-minute slot, which is like 3 contiguous interval periods on all the participants. If it's not available the next 7 days, you would say, sorry, we can't schedule this meeting. So does that make sense? This is the first question that we did last week. I'm just going to switch to the last week's thing. Go on. Any thoughts?
Well, I would think that if you were storing all of the participants' availability in an array, so you knew exactly what position corresponded to that time, and then you look at the first participant and see when they're first available, and then you check the next one over. If they're not available, then you move it up, and that kind of a brute force way.
Mm-hmm. So
that would only account for 30 chunks, though.
Why 30 chunks? I mean, there are 7 days.
30-minute chunks.
30-minute chunks. So 7 days and 24 hours each day times 2. So there are 336 chunks that are available to you. You get a Boolean array which tells you whether someone's participant 1 is available or not available for the next 336 interval periods. So you have that data.
Right.
And the goal here is essentially to keep like an array which talks about okay. So the goal here is to actually figure out what the interval periods are and who's available then. So the solution that we had come up with was that we will keep one Boolean array which will essentially track those times when every participant is available.
Okay.
And then we just linearly scan through that to figure out whether you have a contiguous chunk of 3 or 4 or 5 or as appropriate and deal with it. So that was Q1, easy solution. Anybody who has questions with this? If you do have
I
something.
can see it in my mind.
All right. If you have any questions or concerns, please do chat, type in the chat or anywhere. Just let me know, and we can discuss more. All right. Second question was that how would you change this if we had only a bunch of mandatory participants and there were a whole lot of not mandatory or optional participants, and your idea is to actually set up a meeting time so that so that you can maximize the participation.
So you'd have a set of participants that are mandatory and a set of participants that are optional.
That is correct.
Okay. Okay.
So would you maybe look at the times, figure out the times that all the mandatory people can meet, and then from there look in those times on the non-mandatory people and try to work it out?
Right, but there were like a few traps, so we'll not discuss the solution in detail, but there were two key things. One was a solution that was recommended, which was to have like two arrays, one array which tracks the Boolean flag for mandatory, just like the previous question, but the second one was pretty much like the number of optional participants available and in this interval period, and the goal was to maximize it. It fails because if you have like one optional participant, like 50 optional participants available for hour 1, and then 50 optional participants available for the next 30 minutes, but it's completely different 50 people, then nobody made it. Right? You need the optional participants should be available for the entire meeting, not just for the specific interval period. So the first recommended solution, in the solutioning when we talked about it, we came up with a specific type of solution where we were looking at mandatory participants and optional participants all aggregated. Like mandatory was separate in a Boolean flag, and optional participants were integrated in some sort of integer array, and that solution will not work. So I think the solution that you are talking about, where you would identify all interval periods where the meeting can happen as an item, and then you would look at how many optional participants can make it in that particular interval period, and then you count that, and that's how you find your maximum. I think there's no other good way of doing that. So that's the second solution as such.
Mm-hmm.
Right? And the third question, which is what today's discussion is about, is that what if it was a scenario where you had groups of people, and in order for you to have a meeting, at least one member from each group has to be present. So it's kind of like replaceable people, right?
Okay, so can one person from the group be present the first chunk, and then another person from the group can be present the second chunk, or does it have to be one person for the entire duration?
One person for the entire duration. That's a fantastic question. It is one person for the entire duration. So if it's basically, in order for this meeting to happen, you better have a VP of marketing, you better have a VP of engineering and a VP of this. It doesn't matter which VP of marketing shows up. It doesn't matter which VP of engineering shows up and which quality assurance engineer shows up. It doesn't matter who, but there has to be one person who is representing sort of each of the groups respectively. And another question which I'll preempt is that a member cannot be a part of multiple groups. A member is actually sort of a subset of a group, as in will belong to one and only one group. So you will not have a member who is a quality assurance engineer and a developer and a VP of marketing at the same time. Not that it makes a difference, but right?
So what we can do here is that given a group, we can participate a union of all the available time slots for individual members into the from the group, right? For example, if one member of the group is available at 1 o'clock, the other member is available at 3 o'clock, you can just say that the group is available at either 1 o'clock or 3 o'clock.
Mm-hmm.
Okay. Okay. Any questions? Any concerns with this approach? So how would you ensure that your can you just walk through the solution again? Give me with an example.
So, for example, for every group, this is sort of an extension of the previous one, like it's a layered approach. Like, imagine this as a layered approach, right? Initially, for every individual user, we were able to look at that person's calendar and get their available time, right? What we do is that we sort of pre-process the data, where we first look at all the members of the group and then calculate their available timings and get a union of the timings which are available and represent them as the group's available timing.
Okay.
And then
your condition would be what? And or?
Or. Union is or, right?
Yes, but sure. Just to be on the for clarity, okay. If you're doing or, how would you protect yourself against having like John available for the first 30 minutes and Tom available for the next 30 minutes?
No, we know the duration of the meeting, right? We say that all participants are available at what time for like 1 hour or 1 hour and 30 minutes, right?
Mm-hmm.
Because that will avoid like the half participation and all those things. Whenever we look for availability, we look for into the chunk of the duration of the meeting.
Makes sense. Okay. And how will this question change if you are trying to, if you have a scenario where you are, how will it change the situation if you have same participant in multiple groups?
Like in that case, it doesn't matter, right? Like that participant is representing both the groups.
That should be that will be a clarification question to say that if I have John, who happens to be a marketing executive and a director, do you think can I count him as both if he just participates once?
Okay.
I mean, imagine this is like a scenario of where you're trying to play a game, right? Which has like different positions that people have to play. So I can be a pilot, I can be a co-pilot, I can be a navigator, I can man the guns or whatever else. But in order for us to play the game, I cannot be both at the same time, right?
Yeah. Usually, what happens is that because of the problem statement fed meeting, there are like some assumptions which go with the meeting, right? So I went with that, and I did not.
No, that is fine. So again, the purpose of this question and also the motivation behind the discussion is actually for us to figure out how we can like kind of quickly diversify our thought process. So when we start thinking about meetings and about design and how it works, you need to be able to switch your frame of reference pretty quickly. So in this case, if the solution that you provided, it works. Now, if you change the conversation to saying that what if the same person is multiple groups, your algorithm and approach works as long as you can like multi-represent, as in you can be the director and the marketing guy at the same time, you're fine. But what if you cannot multi-represent?
If you cannot multi-represent, like you can be either.
So Raj's suggestion is once a user represents one group, you should remove him from other groups. But what if his presence in the current group or the first group is not?
Yeah, then it becomes n square and then linear solution, right? I cannot multi-process. And then actually in that case I cannot even group because Raj is in both the groups. There could be another person who is in just one group and both of them have availability at the same time. So it doesn't affect the solution. So now I have to process one user by one user somehow, or I need to process. It makes the solution really difficult because now we cannot optimize for it at a group level. So what I will do in this scenario is I will keep those kind of people as a backup. So I will get the timings of a group with the shared folks and without the shared folks, and I will include the shared folks only in the case where I don't have a common timing.
So just
the question is to find the earliest time slot when you have the quorum.
So I just joined. So we are going back to the question from the previous week, is it?
We are actually repeating what we discussed last week was the first two parts of the question, and the third part of the question was what's something that we left for exercise, and that's the one that we're talking about now, which is you have groups of people, and your goal is actually to find a quorum where at least one member from each group is available. And what we have changed the question subtly is that in addition to saying that members of each group, we are also saying that each participant can be in multiple groups, and we need a representative from each group compulsorily. As in, pretend that this is a game of soccer. Then you would have some people who are defenders, goalkeepers, and whatever else. There could be someone who's competent as a goalkeeper and a defender, right? They may be part of that group, but you will need one person to be a defender and one person to be a goalkeeper. So the meeting compulsorily must contain n number of people, and there are n groups. So how will you make that happen is the question. So a few thoughts were thrown out, saying the first thought was once the user comes in a group, then you actually boot him out of the other groups and then figure out how to solve it, but then you don't know which works where. The next sort of suggestion from what I hear is that you will keep all the people who are just the solos in one way, and then you will keep all the multi-players or multi-skilled people in another group and do some magic with it. That's what I heard. Does that make sense, Nate?
Yeah. Thank you. That makes sense.
All right, awesome. So please carry on with the discussion. So who was actually presenting their ideas?
Actually, it was me, Navneet.
Okay.
So
go ahead.
Now what we are going to do is that now we have this. So we'll come to a solution where we have a possible solution with the people who are not shared, who are not common in any other groups. And then what we'll do is that then we can go for a brute force approach because I'm assuming there will be less number of the people who are going to be shared, who are going to be common across groups. Then we can go for brute force and try plugging them into one or the other group and then see if we can come to a solution which is even more optimized. We can find the earlier time. Yeah. But this will not work for the worst case scenario where everyone is part of all the other groups.
If everyone is part of every group, then you're actually in a bit of a bind here, right? So this actually will revert back to some sort of a combination problem, I guess, where you can generate all possible quorums, right? What defines a quorum? You can generate all the possible combinations based on the group statistics. And then you can figure out when is the earliest time each of the quorums can meet as mandatory, and then you can go ahead and figure out which one of them is the earliest. I mean, that's like a super brute force algorithm.
Yeah. Because in this scenario as well, when we are generating combinations, how are we going to generate combinations which are sort of not double counting any common participants? Because generating combinations for that scenario is going to be even more difficult.
It's not really, right? I mean, it's not really that hard, because what you would be doing is essentially the quorum will contain you or will not contain you. Yeah. That is basically the question, right? And then if you are a part of the quorum, then it will contain you as your role 1 or role 2 or role 3 or role 4 or so on. And then once you have fixed your role, you can select everybody from, you can select one person from each group. So it's just a basic iteration, right?
Yeah.
It's a standard combination thing, right? I mean, how would you select, given a bag of colored balls, how would you pick one ball of each color? How many ways can you pick different colored balls or things like that? I mean, it's one of those questions. It's a pretty standard combination generation thing where you should be able to create all possible quorums, and then you should be able to go through each quorum and see when is the earliest that they can meet, and then pick the quorum that actually has the best possible way of best possible chance of meeting. earliest possible opportunity to meet. That's like a brute force way of solving this. Does that make sense?
Mm-hmm.
Okay, so
Yep.
I think there's not much in this design question. We just wanted to spend a little tad bit of time just going through this and making sure. We didn't have enough time to cover this design last time.
What is the best answer that you heard from any other candidate, like when you were, like, in case if you have presented this question in an interview, did you hear any clever answer? Or
I don't think that, I mean, there are actually no clever answers for these, right? These are the constraints are something that are different. So I introduce these constraints and generally expect the candidate to follow along the constraints and start coming up with different approaches to solve the problem. And the faster they make the leap, the better it is. So the hardest part of design questions is actually to keep the solution in your head like straight and just like linked in the right way, so that when a fundamental assumption gets invalidated, like we talked about 30-minute chunks, right? What if I change that back to saying it is any 30 minutes, but it could be like 7:41 through 8:11 or something like that. If I change that aspect of it, you should be able to immediately go back and see which constraints would be violated. Like so you made certain assumptions, the 336 interval periods is the one that gets violated in this case.
Yeah, I'm not able to think of an algorithm per se, but also you don't have to do the full brute force, right? Because the thing is that you're trying to generate a quorum. You can do it incrementally, and once if a subset is, if you already, for a given subset, if you already found a quorum of it, which is a superset, that is better than whatever the subset is coming out to, then you can kind of prune it out, right? You don't have to expand all the other quorums that might contain it. I mean, you can throw
Correct.
off something.
Correct. You can throw off a lot of things. Like a couple of things you can do, right? Number one is you can, as a part of the quorum, right? If person A and person B have absolutely no overlapping meetings, no overlapping free slots, right? Any solution that involves A and B is not possible.
Correct.
Mm-hmm.
Yeah, that's what.
Right? And you should be able to like quickly prune off by smartly trying to check the people with the least availability first, and then go through. You can probably do that.
Mm.
Another thing is that the moment you find that somebody can meet 3 days from now, right? For all the other solutions you're exploring, you don't have to explore all the entire 7 days. You can just explore the first 3 days, as long as you have checked that like this group B or group C or group D cannot meet in the first 3 days. You can just ignore them after that. You don't have to check when is the earliest possible time that group X can meet, because you already have found group, I don't know, M, which can meet 3 days from now. Right?
So is that one?
will that not make the solution like sequential, where I cannot like process the other groups in parallel? So there is that optimization that we lose if we.
Correct. It's a good point. But the thing is that you will, the biggest challenge that you'll have in this scenario is that you are only trying to this is kind of a trivial optimization which might actually improve your average case, but it will not improve your worst case, because it is possible to engineer a solution where this particular optimization will actually not help you in any way, right? Like if you look at algorithms like quicksort, the worst case time complexity for quicksort is, anybody?
N square.
Why?
No, worst case is if you because it's quite possible that you use you partition the element, but you choose the maximum or the.
Even though you're picking it at random, it is quite likely. I mean, if your luck were to be so horrible that you could potentially be picking like the smallest or the largest element every time, and the partitioning is not really helping you at all.
Mm-hmm.
Right. So while that is possible, so it's always possible in such this comes in a class of optimizations where you are kind of optimizing sort of for the normal case and not for the worst case. Okay.
Mm-hmm.
All right. So any other questions or concerns about this question, about the design question? Sweet. Then what we'll do is let's move to the coding question then, right? So the question that I have is, it is a dynamic programming question, and the objective here is that you're given bricks, and the bricks are of dimension 1 foot by 2 foot, whatever dimension is 1 by 2, and or 2 by 1 depending on which orientation you keep them, and you can your goal is to actually lay them on a narrow path of 2 foot wide path, and it's got like the question says 100 foot, but your goal is actually to generically define what would it be to do like a n foot system, right? So in a very simple case, if you had to lay out a 2 foot by 2 foot path, then you can actually either tile those 2 bricks horizontally, or you can tile them vertically, like side by side or one on top of another, and that essentially would be 2 different ways of doing it, right? Anybody who has not followed this part? Okay. All right. So that's what it is. So now, if you had 3 tiles or 4 tiles or whatever, you can do it in many different ways. So how would you go about solving this? Any volunteers? Any takers? Silence.
We can start by solving like for small problems, like if the length is 1 feet, 2 feet, 1 feet by 2 feet, then we can solve it by only one way, right?
I'm typing in line number 21 at this point of time. So if you guys are actually on the thing, if you're seeing my screen, you're fine. Or if you're on the Etherpad, you could look at line 20, 21, okay? So there's only one way to solve it. Essentially, you would do it by like that, right? 1 and 1, vertically. Okay? If you have 2 foot by 2 foot, then it is, how do you solve 2 foot by 2 foot? Like that, side by side, or that. So we knew this. It's given, the question has this status, this data. What about what's the next one? Go ahead. Go ahead. I mean, you have whoever was speaking.
Yeah. So for 2 foot by 3 feet, we can combine the result from 1 and 2 foot, right? So we can either do like all 1 foot, and the first one 1 foot, the second one 1 foot by 2 foot. I mean, horizontally.
I'm not following. Okay, you might. Can you elaborate or can you explain?
Combination would be like the first one would be all vertical, right?
Okay.
One,
so that's 1, 2, 2, 3, 3. Got it. What's the next one?
The second one would be like 1, 1. Then 2, 2 would be like horizontal.
Okay. Done.
And 3, 3 would be vertical. Yeah.
Okay. And those are the 3 combinations. But how did I generate this from the previous one?
So we can so
like to go to 4, we will have to invalidate, like we cannot use a 3, right? Because if we use the solution for 3, in the solution for 3 will always have one horizontal, right?
Not really, right? Solution for 3 actually has all 3 verticals here.
No. If you have
33,
3 feet, no. If you have 3 feet, like 3 feet by 2 feet. So you will have to have one horizontal.
It will be there. So no. So you have like, do you want to do 3 foot by 3 foot? Do you want to do that?
No, 3 foot by 2 foot. I'm saying.
Sorry, 2 foot by 3. No. Hang on. It's always 2 tall, and it's only 3 and x wide. The path is narrow. So it's, you are not asked to solve a 3 by 3. You will always be asked to solve a 2 by x. So the next thing to solve is 2 by 4. Okay, how would you solve 2 by 4?
So 2 by 4 I can solve only by, like, I cannot use a solution for 3. I can use only solution for 2, and on top of it I can see how many combinations there are for next 2.
Why not? Why can't you use a solution for 3?
Because for solution for 3, in the solution for 3, the tile cannot be horizontally put in. Sorry, the tile cannot be vertically put in. What if I have to use a solution for 3? The only way to use solution for 3 is to put one tile horizontal. There is no other way I can build a solution for 3.
Vertical, yeah, but yeah, sure. Horizontal, vertical, everything, orientation. So you can only add one tile to it along the axis, okay?
Yes, right.
Okay.
So I cannot use a solution for that for 4, because I cannot, in 4, I need to come up with a solution which is, I need to change the orientation of the third tile.
And I know, folks, a lot of you are actually new to my style of actually operation. When I say okay, it does not mean that I'm agreeing with you. All it means is that I understand what you're saying. All right, you may be entirely wrong, and I'll still say okay. All right, carry on. Just FYI. Go ahead. So how would you actually go from a 2 by 2 solution to a 2 by 4 solution then?
That's what I'm thinking right now.
Is there anybody else with a different approach?
So there is 2 orientations, right? I mean, if I got the problem right, I mean, it's like 1 by 2 or 2 by 1.
Correct.
Right. So your current state of wherever you come could come because you added one more, which was 1 by 2 in one orientation, or the other orientation. There's two cases for your recurrence. Right?
No,
so,
can you rephrase that? Sorry, I missed that part of it. Can you repeat that last one?
I'm saying that you have 2 possible orientations, right? It can be either horizontal or vertical.
Right.
Right. So however you come to if your state is 2 by 4, right?
Hmm?
You could have come either from you could have come there because you placed from what's the if you had started with so let me try to 1 second.
So basically you can come to 2 by 4 by either from 2 by 3 or 2 by 2, right? Like the last piece of, I mean the rightmost piece of block you are setting, you can either set it horizontally or vertically.
Yeah.
If you put it vertically, then you can come from 2 by 3, and if you put it horizontally, then you will have to come from 2 by 2, right?
Right. Yeah. So those are the 2 cases.
Yeah.
Right. So I mean, so that
people understand this?
Yeah, this will be the.
Actually, don't understand this.
Okay, so here are a couple of things to remember about dynamic programming, right? So when we talk about dynamic programming, one of the key things for us to remember is that you need to find a way to the goal is that if you know how to solve like a bigger problem, right? Your goal at this point of time is to find the number of ways in which you can actually arrange n bricks is your goal, right? And you should be able to compute that using some kind of a mathematical formula that is using all the ways that you've done before between 1 and n, or maybe 0 and n, as the case may be. That's the first element. That's what you're trying to do. In dynamic programming, you're trying to kind of define some kind of a recursive function or some kind of a recurrence that is using a smaller value. That is consideration number 1. Consideration number 2 is that each of those individual elements that you're trying to do, they should be completely separate. They should be discrete groups, and there should be no overlap between the combinations that is generated by one group versus the other. So in this case, what we were actually saying was that if you were to generate 2 cross n kind of a scenario, right? what do you think is the orientation of the last two bricks? The last two bricks can either be a parallel like this. I'm on line 48. Parallel as in horizontal parallel, or it could be vertical. I'm in line 49. Those are the two possibilities, right?
Correct.
Yeah.
Okay. Now, how would you and what about the stuff before this?
That's already solved.
Yes.
That's the solution for ways of what?
Ways of ways of n minus 2.
That is ways of n minus 2. But here is one thing to understand, that this does not mean that the last two has to be parallel. Only the last one has to be parallel, not last two.
What do you mean by last?
The last, if it's vertical, then it's only one brick vertical is possible, right? So you can solve for ways of n minus 3, and then you can just add a vertical brick at the end of it.
That is also a way. That is what you're trying to approach, right? That is what
that is a way of making four, like the way, not n minus 3, sorry, n minus 1.
N minus 1.
Yeah, n minus 1.
Sorry.
Yeah, Ramo, it's a Fibonacci series actually.
It is actually a Fibonacci series. So it's ways of n is equals ways of n minus 1 plus ways of n minus 2, right? And this is the famous Fibonacci series. And the reason why it is like this is because what you're saying is that essentially what you do is you arrange you use all the ways of n minus 2 first. Once you do that, you can just put two bricks horizontally, one on top of another, and you have solved it for 4 now, or for n. Then you actually arrange it in ways of n minus 1, and then you put one brick in the end, and you have solved it for, again, ways of n. Can there be an overlap between these two data sets?
Yes, there could be overlap, yeah.
Why? How? There will be no overlap, right? The solution for everything in n minus 2 involves the last two bricks being parallel. The solution for everything in the bottom involves the last rightmost column being vertical. So there is no way that these two can overlap.
Yeah, I was thinking from a DP point.
The last brick was vertical last brick was vertical, right? For even the n minus 2 case.
Not really. The n minus 2 is actually not the last brick. The third last brick can be vertical. The second last and the last bricks will always be horizontal, right? Because that's how you've set it.
Yeah.
You've solved for n minus 2. You have two spots left. You are only putting it horizontally now. So that means the last brick cannot be vertical in the first group of solutions. Does that make sense?
Yes.
Yeah, I mean overlap in a sense,
take an example of say maybe.
So when you're solving for ways of n minus 1, you're solving for n minus 2 and n minus 3. In that case, your n minus 1 is being solved once on n and once on n minus 1. When you're solving n minus 2, you're solving n minus 2 and when you're solving n minus 1, you're solving n minus 2 and n minus 3. When you're solving n, you're solving n minus 1 and n minus 2. In that sense, there is an overlap, right? I mean,
Fair enough. Now, is there anybody here who actually has not gotten this aspect of it? We can take an example and solve it, or I can move to like a variation of this question.
Actually,
is there anyone who wants to
example and solve it?
Let's sure, absolutely, right? So, what is ways of 1? It's just 1 and 1, correct? What is ways of 2? Ways of 2 is what?
1 and 2.
Ways of 0 is like just blank. Okay. Ways of 2 is, what is ways of 2? It is actually ways of n minus 2. What is ways of n minus 2? Which is blank, right? And then you lay both the bricks horizontal. 64 and 65. Correct? Line number 67 is actually ways of 1 followed by just one brick, horizontal, vertical bricks, and that's it. So ways of, there are only two ways to arrange two bricks. Correct?
Yes.
But case of the ways of 1, how it is 1 and 1? because you're not generating 2 feet wide, right?
So you can place both the bricks horizontally or vertically.
So I think your response and your orientation, my orientation are different. So I'm looking at in the horizontal axis is actually x long. In the vertical axis is always just 2 tall. Okay. So in ways of 1, I am building a 2 tall, 1 wide structure, which is 1 1, right? Line number 60.
2 tall, 1 wide. So what's the dimension of a brick? Is it like in your dimension? What's the dimension of a brick?
It's 1 2, and I can keep it whichever way I want.
Okay.
Oh, now I think I see it. Yeah.
Yeah, I mean the numbers where it's the same number. That is the index of the brick. Like 1 1.
Same number is the same brick.
Yeah.
1 1 is the first brick, 2 2 is the second brick, 3 3 is the third brick, and so on.
Okay,
Sorry, I should have been clearer there.
Yeah.
Okay. Okay. I could. Yeah, that's what it is. 1 represents first brick, 2 represents second brick, 3 represents third brick, and you will find that I will put the brick adjacent to each other always, so that's how it represents a 2 by 1 matrix. Okay. So the ways of 3, right? How do you do ways of 3? Is you solve ways of 1, which is essentially this way, and then you put the 2 bricks horizontally. 2 2 goes this way, 3 3 goes this way. Or you solve ways of 2, which is this and this, right? And I add the third brick at the end. So that's that and that. There's only 3 ways to do ways of 3.
Yeah.
So you're copying the subproblems and then adding one new
I'm just
step,
yeah,
correct?
that is correct. So I'm copying the 2 subproblems before, and I'm adding 2 horizontal bricks for the first one, and the one vertical brick for the second one. Right? In order for you to go from ways of x to ways of x plus 1, you just have to add 1 vertical brick in the end. In order for you to go from the x to x plus 2, you have to add 2 horizontal bricks, and that's about it. That makes sense?
Yeah.
Mm-hmm.
All right. So there was a question which is about someone said, why can't we have them vertical in ways of 2? Did that get answered? I believe so. The 64, 65 represents the horizontal representation. 66, 67, 68 represents the vertical representation. All right. Now, if I change the question to say that you need to pave a 3 cross n road with 3 cross 1 bricks. Okay, how do you solve this? This is like a logical extension of what we just did. And if you understand the way it's solved and just not memorizing the solution, then you should be able to extrapolate this. So how would you solve a 3 cross 1 brick? Given 3 cross 1 brick, how do you do a 3 cross n road? Go.
Okay,
Anyone?
so
I mean,
just a sec. Way
so again Fibonacci, right?
I'm coming.
Is it Fibonacci?
Just
I mean,
add n minus 1 plus n minus.
So why don't you take a few minutes, if you have a paper and pen, or just use a different area of the scratch pad, type down what you think through it, and then come back. In an interview, your goal should be that you can't just blurt out the first idea that comes in your head. You need to run it through like a basic sanity filter, and then start speaking. So there's a balance there. I mean, you can't solve the problem and then come and present to the interviewer, because that's going to be too late. And you can't just blurt out the first idea that comes in your head, because that might not be right. So there is a little bit of a sanity filter there. So I'm just suggesting or recommending that you guys take 30 seconds, a minute, to write down the solution on paper. If you have a paper and pen handy, just draw the bricks out and see. Define the recurrence formula. We just derived how to do it for 2, right? Can you derive it in the same way for 3? And you should be able to leap to that, quickly decide if you're going in the right direction or not. Okay? So is there anyone who actually wants to give it a shot?
Mm-hmm. minute. I'm still thinking.
Perfect. I like it. And that is perfectly fine. In an interview, when someone actually is trying to pressure you into what you're doing, like, give me a minute, let me just think through this. It's perfectly fine to say. As long as it's not the entire interview you're not thinking, it's acceptable.
Okay, I'm just thinking out loud. Way of 0 is blank. Way of 1 is there's just one way. Way of 2 is just one way. Because you can only put them vertically. Way of 3, there's 2 ways.
Is that not 3 ways for way of 3?
Way of 2 is just one way. I'm on line number 80, 81, 82. So way of 3 is how many ways?
I'm only seeing 2 right now.
Yeah, I'm only seeing 2 too.
So it's way of 2 plus a horizontal line and I'm just putting a double equals, but it's actually triple equals.
Which is wave
right?
plus 1 and wave.
Something like that. See, I found a triple bar.
What do you mean by the second part of the wave? Wave 3, wave n minus 3 plus equals.
So the essentially what you're doing, I think, I guess it's Ramya who's typing the formula. So ways of n is essentially what you're doing. You can define the n minus 1, and after you've defined n minus 1, you can just put one horizontal brick and you're good, right? Or you define n minus 3, and then you keep 3 horizontal bars, a vertical or horizontal bars in that case, and that's it. So it's kind of like Fibonacci, but not really, because it's actually ways of n is ways of n minus 1 plus ways of n minus 3 in this case. So anyone who has Vamshi, why do you think there will be an additional ways of n minus 3 in the recurrence? Just saw your note. So anyone who actually is, so the formula is correct. And anyone who actually, go ahead.
So it's not defined for n greater than equal to n less than equal to 0.
It's not. It's actually 0 for n less than or equal to 0. Correct.
No, even for you can't plug 2 in the formula also, right? Or 1 or 1 or 2 in the formula. So 1 and 2 are also like, you have to define them.
No, it is. You don't have to. That's it. It's
okay.
It's defined, right? Anything less than 1 is 0. Like 0 and negative is all 0. And base of 1 is actually, what is base of 1? That is 1. That's hard coded. Base of 2 is base of 1 plus
1.
Base of minus 1.
Base of minus 1, which is 0, which we have established. Okay.
Which is 1, right? So you don't have to go any more than that. This is more than adequate.
Okay.
Okay. All right. Was that fun?
That was good.
Yes. Not really. Not really. All right.
Takes a while to wrap your head around these DP problems.
That is correct. These are basically very simple questions. These are very straightforward. If you're able to, I think the key here, the trick is actually to identify the recurrence formula and find a way to build a bigger element out of the smaller element or elements, and see how you can do that. And the biggest thing you have to make sure is that none of the sets or subsets that you're trying to generate should overlap. If you do that, then if the overlaps, if you ensure that there's no overlaps, then you'll get to the right answer pretty quickly, right? All right, so let's jump on to the next question. This one is we will not be coding in today's class because of the way the problems are. I think we're only looking at problem solving. I do want to keep the next class as something with a little bit more coding involved. But let's give it a shot for the second question. So this is again a very classic question. The question is basically that you have like a large roll of cloth of n feet, and the problem has been given in like it could be like a plank of wood, or it could be a rod of iron or something. I mean, different people use different ways of depicting the same thing, but essentially what you're looking at is you're given a big bundle of cloth, and you're given the price for different lengths. So if you're given an 8-foot cloth, the price, if you look at the line, it says hang on 1 second. Let me just complete the question and I'll read the recommendation. So clearly 0 will be 0, which means that you want to say that length of 0 is actually not worth anything. But then 1-foot cloth is worth $3, 2-foot cloth is worth $7, 3-foot cloth is worth $8, 4-foot is $9, 5-foot is 12, 6 is 17. Whoever is typing, can you just rename yourself so it's easier for me to refer? I would rather call you something rather than unnamed. 7 is 17 and 8 is 20. Now you're given 8 foot of cloth, right? What is the default value of this bundle of cloth that you have? It's $20, right? If you don't do anything with it, it's $20. However, if you cut it into 2 pieces of 6 and 2, you will be able to sell the $6-foot piece for $17 and the 7-foot piece for $7, making it $24. That's not the best. You can actually do better than that. Do you know that how would you do better than that?
You would.
Anyone with any thoughts as to how you can make it better? And then we can go back and do it algorithmically. But
better than $24?
Yeah. If I give you 8 foot of cloth, you should be able to make more.
Yeah, can you just cut it into all pieces of 2?
That is correct. You can cut it into 4 pieces of 2, and that is 7 times 4. That is $28. That's better than this. Okay? Humans are inherently smart at actually trying to quickly arrive at a solution for this. How would you code it up? How would you make a computer react to arbitrary values like this? And if I tweak the parameters, your solution is no longer valid, so you need to write an algorithm to arrive at that. How would you do that?
Well, I mean, just looking at it, I think the way I figured it out in my head was just looking at all the pieces and seeing what piece gave me the most value that I cut it into. I guess that's a start, maybe.
Interesting. That is good, but that may not always be possible. In this case, it was 8 foot, right? Had it been like a 7-foot cloth, then you have multiple options, and then you may it's a different beast after that. But that's a clever way of looking at it. Absolutely. So the thing was that I was looking at which one actually gives you more dollar per foot, and turns out that the 2 actually gives you the best value. And it so happens that fortunately in this case you're able to cut it in exactly that way, so you're fine. But that's.
Is this another way? I'm just remembering when I did something similar to this in school. Is it like you, again, like we talked about before with another problem where you should list out all the combinations and then you look for a path between them, that if that makes sense, if you were to put it out on like a board to see how you cut it up?
So yes, that is a solution, and that is pretty darn near close to the brute force solution that you're looking at, or actually it is the brute force solution where you're trying to figure out how many ways you can chop this up and things like that, and solve it. But I think there is a cleverer way of doing it than to actually completely enumerate all possible combinations. Like you don't want to go with 1 times 8. Okay, then it's like 1. I don't know how, it's like, 1 piece, which is 8 foot is one option. Then 1 piece, which is 7 foot, plus 1 piece, that's 1 foot, is another option, and so on and so forth, right? So you'll be generating bajillion combinations, which actually, you can be cleverer than that.
So Vivek,
Yes, go ahead.
I just want to backtrack to the previous problem a little bit. Can I?
Yeah, go ahead.
Yeah. So if you look at way of 3, right?
Mm-hmm.
What I mean, we are looking to construct a 3 by 3 road, right? If it's way of 3.
Correct.
Now 3 by 3 road can be like you lay 3 vertical strips of 3 cross 1.
Correct.
Or you lay 3 horizontal strips of 3 cross 1.
Correct.
That gives you 2 ways.
That is correct.
Now, if you look at the recurrence there, it is way of n minus 1 plus way of n minus 3, which is only one way.
I see what you're saying. No, good catch. So in this case, right, I think the
No,
I think you'll have to define way of 3 as well. I think the point was you have to define that, because this is, even though there's no good way of doing way of n minus 3, which n minus 0 in this case, you'll have to define way of 0, 1, 2, and 3, and then after that everything will follow. You're correct.
Okay.
Anything after 4 will follow. 1, 0, 1, 2, and 3. You have to define it. You have to hard code that.
About this cloth solution, what's the answer? Is it 24 for this?
It's not 24, right? It's 28, because I didn't catch the name, but one of the solution is you can actually convert it to 2 plus 2 plus 2 plus 2, and each of them is like $7 worth, times 4 is actually $28. So the answer is $28 in this case. For 8-foot cloth, it's $28, and that's because of the solution. So 6 and 2 is definitely better than 8, but then by cutting it into 4, 2, 2, 2, 2, 2, you actually make more, and that's more valuable. So let me ask you a kind of an interesting question. What if it was a 6-foot cloth?
You would say that basically take subtract the length from 8, whatever the difference was. You would just add 7 to whatever your answer was for 6.
Right. So the way I'm looking at this is that if you, for 6, right, if you had a 6-foot cloth, you can make $17 by not cutting it. Correct? If you cut it,
yes.
What can you make?
If we use 6 1-feet cloth, then we will get
80.
Can you repeat the question,
Okay.
Rick?
Yeah. Okay. So Nate, I just put you on mute because there's a lot of background noise from your side. So yeah. So the question is that if I give you 6-foot cloth, not 8-foot, if I give you a 6-foot cloth, what is the best you can do? It's $21, right?
You can cut it into 3, 2, and 1.
3, 2, and 1. Why?
Yeah, that makes it 18, bigger than 17.
Yeah, but 2, 2, and 2 makes it
21. Okay.
that's better, right?
Okay.
So the best value that you can do is 21. So if you knew that the best value you can do with 6 is 21, not the price but best value, then the solution for 2 plus 6 actually is the same, right? It's 21 plus 7, which is 28.
Yes.
So you would.
So you don't have to.
Yeah.
So go on.
So you would take a particular length of the cloth, subtract it from the length of the subtract it from the total length of the cloth, and assume that you hope that you already solved the problem. Right? Imagine that you already solved the problem for that length minus the current length, and you already stored that problem. Like in this case, you already stored the value of 21 somewhere, and you just wanted to add this new length of 2, and you.
How did you choose 2? Why is it not? Why did you not try with 5 and 3? Why did you try with 6 and 2?
Because it's a maximum. So you try 5 plus 3, you calculate the value for 5, you calculate the value for 4, you calculate the value for 3, 7.
So in this case, you would want to go like bottom up as opposed to top down. So instead of starting from the end, I would start from the beginning, and I would say that if I have 0, the price is 0, the best value I can get is 0. If it's 1, the price is 1, what is the best value I can get?
If it's 1, that's
$3.
$3. That's it. Yeah.
$3.
Yeah, if it's 2, then the price is 7. What is the best value I can get? I can cut it into 2 halves and make $6 out of it. Or
I just want to leave it.
Or I leave it as is and make $7 out of it. If it's 3, what do I do?
You can cut it into chops of 1 or 2 and 1 or 3 itself. There are 3 possibilities, right?
So which is better? Which is the better of the 3?
Obviously, chops of 1. No, wait. 2 plus 1.
1, 1, 1.
No, 2 plus 1.
No, 2 plus 1 is 10, and yeah. So if I cut it, if I make it 2 plus 1, then best I can make is 10. If I do 1, 1, 1, then best I can make is 9. If I leave it as is, I'll make 8. So obviously $10 is, I'll take 10. Okay. Now for 4, what is it? The value is 9. What's the best
3
value?
3 plus 1. 4 is 3 plus 1 or 2 plus 2?
2 plus 2. 2 plus 2. 2 plus 2, 3 plus 1 or 4. So the best is 2 plus 2.
So like, but basically still in this scenario as well, we are checking all the previous, like all the coins, right? Or all
we are not checking all, but it is an n square pass. We are actually checking, you are only checking up to half, but still, you're checking n by 2. It's no different. Right? So you have to go all the way up to the half. Korean?
Must have missed that. How did you get 14 for that one?
2 and 2. 7 plus 7 is 14.
We are like, why we are going like the length of this array? Why we don't just subtract the denominations of the cloth that we have, like 1, 2, 3, 4, 5. Oh, like assuming like right now these denominations are in sequential, like 1, 2, 3, 4, 5. Assuming that would be 1, 3, and 5. In that case, I will be always subtracting.
So essentially what you need to do is, fine. So in this case it's sequential. Let's complete this part. Let's complete this and then let's complicate it afterwards, right? Okay. For 5, so somebody asked a question. Is 14 clear? Why 4 is 14? 7 and 7.
Go over it quick.
It's 7 and 7, right? The way I can do 14, the 4, is I can do just one piece of 4. I can do 1 plus 3, or I can do 2 plus 2.
2
right?
plus 2.
If I just keep it as 4, it's $9. If I do 1 and 3, that's $13. And if I do 2 plus 2, that's 14.
Okay. Thank you.
Yeah. You're welcome. 15, for 5, it's $12. And the way I can do 5 is keep it as 5, keep it as 1 plus 4, or 2 plus 3. That's it. Which is better?
You can do 1, 2, and 2.
You don't have to do 1, 2, and 2 because the 1, 2, and 2 is already covered by the 3. The best value for 3 is covered.
Okay.
The advantage of this approach is that the 1, 2, and 2 is already covered because you are now, since you're going through the best value system, you don't have to enumerate all possible combinations. So this is why this is better than brute force.
So you just do 2 and...
So you just have to check 1 plus 4 and 2 plus 3. 1 plus 4 in terms of best value is 17. And 2 plus 3 in terms of best value is 17 as well. And the price for it as is 12. So I think the best value is 17. Okay. For 6, if you leave it as is, it's 17. If it's 5 plus 1, it's 20. If it is 3 plus 3, it is 20. If it's 4 plus 2, it's 21. Right? So it is 21. 6 is best value is 21.
Right.
7, price is 17. If you do 6 and 1, it is 24. If you do 5 and 2, that is also 24. If you do 3 and 4, it is also 24. So the best value is 24. For 8, the price is 20. 7 and 1 is 27. 6 and 2 is 28. 5 and 3, 27. 4 and 4 is 28. Okay? So, obviously 8 is 28. So that's how it works. Okay? So are we clear with how we arrived at this?
Yeah.
Easy?
Yes.
All right. Okay. Sorry, I missed a question by Raj. So I think we've covered that aspect. If not, please restate your question, and I'll cover it again. So that's what we have in this case. Now, the question that Navneet had was, what if it's not like linear? What if I didn't have a 3? Like, what if I had just 1, 2, 4, 5, and 6? Like, how would this work? Right? That was the question, right?
Sort of, yes.
Yeah. So if we had like 1, 2, 4, how would it work? So 1 and 2 calculation is the same. That doesn't change. Okay. 3 calculation does not exist.
Yes.
Okay. When it comes time to do the 4 calculation, 4, the price is 9.
No, 3 calculation exists, right? Like, for example, if you have a cloth which is
3 calculation does not exist. 3 calculation does not exist.
Oh, so this is your pre-processing the input?
This is a pre-processing for the price. If you want to find the answer for 3, then sure. Okay. If you want to find the answer for 3, actually you're right. No, you're right. We'll have to make it for all integral values. I will compute 3. The price will be minus infinity.
Yeah.
Okay. And what is the way I can make 3?
Only 2 and 1
either,
or 1, 1, 1.
That's it. 2 and 1. That's it. 1, 1, 1 does not exist.
1, 1, 1.
Because 1, 1, 1 is already covered by 2.
Oh, okay.
Are we clear there? Why do we not compute? Why do we not take 1, 1, 1?
What if one was costing $12 or $8?
If one was costing $8,
oh yeah,
then
yeah.
what is the best price for 8? Then what is the best price for 2? It will be already 16.
Got it. Sorry. My bad.
Okay. No worries.
Mm.
Okay. So the question is, what do you mean by it's already covered, right? So the way you can do 3 is, I'm saying 3 is either it's just 1 plus 2, or it is this plus this plus this, right? When I'm saying 1 plus 1 plus 1 is already covered, we already compared whether the price of 2 is better than the price of 1 plus 1. We already covered that.
Yeah.
Did we not?
Yes.
We did.
That's what it is. Okay. That makes sense?
Yeah, it does.
Okay. So the price of 1 plus price of 2, and the other option is price. So you already covered that as a part of your best value calculation for 2. So you're right. In this case, if data elements are missing, you have to go and you have to assume that it's minus infinity, and calculate the process. Okay. What if I actually had negative costs? How would it make a difference? If I said that having a 1 unit, having just 1 unit, 1 piece left is minus 3. How does that change your equation?
Makes it tricky.
Why would it make it tricky?
It does not actually. It's same.
It's the exact same formula. I mean, 0 is 0. Best value is 0. Actual price is 0. 1. Actual price is minus 3. Best value is minus 3. Okay. 2. Actual price is 7. You will try not to use 1, and in certain scenarios you may use 1 because it is possible to actually split as 2 plus 2 plus 1 as opposed to a 4 plus 3. That might be more profitable than 2 plus 2 plus 1.
Okay.
Or something like that. I mean, we may come up with certain scenarios where it is beneficial to, like, for example, if you had 8 foot of cloth, and 7 foot of cloth is like worth $1 million. All right. You would have a solution that says 7 plus 1, right?
Yeah.
Taking one for the team, like that.
Was that again?
Like taking one for the team, like small loss can lead to big.
Yeah. That is correct. So is this clear? I think it's not a super complicated solution per se, but what it requires is like a conditioning in terms of thinking about building your dynamic problem, the recurrence function, and how to build one from other. So what is the big O of this algorithm?
It is m multiplied by n, like.
It's actually n square, but n is not the number of elements, but actually n is all the linear values that you can compute. Right? Because if instead of it being a 1, 2, 4, 8, if I had it as something like 1, 10, 100, 1 million, 1 billion, you will have to compute all linear values up to 1 billion. Depending on how your data set is, this algorithm may not be the best way of solving it.
Is there a better way to do this?
No, but with memoization, it will help, right? So for example, for example, say it is 100 feet, right? And I have combinations of only 1, 2, and 5. Then what I will do is that I will say, give me minimum, like maximum of 5 minus, like 100 minus 1 for all these 3 combinations, and then 100 minus 2 for all these combinations, and 100 minus 5 for all these combinations.
If I give you a data set like this, right?
Yeah.
Okay. Which is like 0 foot is like $1 and $0, and 1 foot is $1. 10 foot is $2, and 100 is 3, and 1,000 is 4, and 10,000 is 5. That's it. That's all I give you, right? Then there is only one solution possible for any number. If I give you 8765 foot, then it has to be 8 of 4, like 8 of thousands, and 7 of hundreds, and 2 of 6 of tens, and 1 of 5. That's it. So you'll have to look at the memorization, the approach that we talked about will end up generating the answer for every damn combination from 1 all the way up to 10,000, or 1 all the way up to 8765, which will be a ridiculously dumb way of doing it. So in it, you might have to figure out, depending on the data set, the algorithm that we discussed may not be the best algorithm.
Okay. Yep. Agree.
Okay. So in that case, it will become like it's just like you're looking at n times. Essentially, you're looking at something like a solution which is 8765 times 1 is the most number you can do, and it's 876 times this is what you can do, and so on. So you'll have to figure out what is the best rate for each one of them and deal with it. So you may have to use different algorithms for it. So I'm going to leave that out, but in an interview, be prepared. Don't get rat-holed into one solution. If the interviewer is like, it is a dynamic programming problem based on the simple like cutting system, and the cleverness is that. But if I were to be the interviewer and I were to ask this question and your response was this, I would actually immediately change the pattern to do the other one, because what I'm trying to assess is, are you actually are you jumping to the solution based on the problem statement, or are you just reacting to, here I've seen a similar rod problem, and in that problem we use dynamic programming, so I'm going to use dynamic programming. That's it, right? Are you deriving the problem from the first principles, or are you just like jumping to solutions based on what you've seen before? So that makes it harder overall, right?
Yeah.
All right, we got about 15 minutes. Let's get to the third problem. I think RP had a solution in place, so I'm going to let her talk about the question. But the question, let me explain the question, and then I'll yield to her solution. So the question is essentially, you're given sort of an array of numbers. You need to go from the first element in the array to the last element of the array, and at any point of time, you can jump ahead by at most the number that is there in the current location. So if from a of 0, since the value is 2, you can either go to a of 1 or you can go to a of 2. Mm-hmm. Okay, and from a of 1, you can either go to a of 2, a of 3, or a of 4. And in this case, the goal is to actually reach a of 4. So 2 possible routes. If you are trying to take the maximum jump every time, then you would take the double jump in the first case, and then after that it's 2 linear jumps to get to a of 4. That's 3 jumps in total. And the second scenario is when you actually take one for the team, actually do a smaller jump right now, which is you don't do the fullest 2 jumps that you can do, but then that actually gives you the benefit of taking a 3 jump after that and jumping to a of 4. That gives you 2 jumps. Is there anyone who does not understand the question? All right. I have the code in front of me. Arpita, go ahead.
So sorry about the way I have wrote. I just wrote it very fast. So first of all, I have a recursive solution for this. I did not write a dynamic programming memoization solution for it. So I'm passing the array, I'm passing the starting index and the end position. So end position is always fixed, which is basically the end of the array, but the start will change as we calculate. So if the start and the end positions are same, then we return a 0 because there will be no jump at all. If the value in the start position, so if the value in start position is 0, that means it is saying that you do not need to jump. So this could be at any point in time. It could be in between when we are computing, or it could be just in the beginning when we have started computing. So whenever it happens, we'll return the minimum value. And I'm sorry about that. I wanted to initialize the minimum value up there. So I have an arrow.
What is minimum value?
If you go a little bit down, if you go down, so that's the minimum value which I wanted to just go a little bit up.
That's fine. So you have a different minimum value. Okay, go ahead.
Yeah, so I just put minimum value as the length of the array plus just a random value, because if we have a array of say 100 values, then we will not have jump more than 100 jumps. So I will just write array.length plus some random value. So that's the minimum.
Go on.
Now, so as we know that in the array, so for example, if our start point is, say for example, it's the 5th position. So what will be the array of the value at the 5th position will tell us, okay, you can jump by this many positions, right? Or you can jump at most to this position. So I'm fetching that in a variable curve_val. So it will tell me, okay, from this start position, you can go up to 5 positions, say. Then the current position is just a variable to take start. So now we know that whatever position we have to start from, by looking at the value, we know we can go to at most that particular position. So what we will do is for each, since it is at most, so between whatever the array elements are there, we will get that and we will compute minimum jump for that. So I'm computing, so for the current position plus the next position, so from the next position of the current position till the end, and before the value that is in the array. So I is less than equal to current val plus current position. So current position is start, plus we know that current val will give us the maximum number of jumps we can take, the array that we can traverse. So that will be I is less than current val plus current position, and then we implement it. So the jumps, I would compute jumps for each of that position. So each of, I'll pass the array, I'll pass the start position as I. So I would vary from the current position plus 1 to the position where we want to jump. So it will compute the jumps, and if since I had already set minimum, so minimum will be computed again here. So if jumps is less than minimum, then we will set minimum again. So for all those iterations, minimum will be set, and at the end we just return minimum. So that will give us the minimum value, minimum number of jumps.
Any concerns, any questions, any thoughts? Is this a brute force solution?
Yeah.
Because you're enumerating every possibility, right?
Yeah, so not every possibility, but I can write down the example and I can show it that way also, just to explain.
No, you're actually computing every possibility in the sense that you're actually enumerating all ways, or the number of ways in which you can go from the first location to all the way to the end, and you're figuring it out.
Not all the way to the end. Not all the way to the end, because in the condition I have written I is less than end and I is less than current value plus current position, which is basically telling, yeah. So if we, yeah.
So I'll leave the solution here and we'll come back to the solution in a second. But anybody else with a cleverer, smarter, simpler, easier solution?
I came up with a solution. Shall I talk about this?
But can we just add memoization to this one, and will that not help?
Well, that will. Yeah, that will definitely, but that's the next step. So I thought that I'll write a recursive solution first and then add memoization to it.
Will memorization help?
Yeah, because you will so if you like before if we just add at the top of this, if you already have a calculated value for the ith location, you don't need to calculate it again, right?
Okay, so since she's using a recursive solution, right? So imagine a scenario where I have 100 in the first location, okay? And then I have 1, 1, 1, 1, 1, 1, 1, 1, all the way till the end of the array, okay? And the array is like 200 long or something like that, okay? So now, because of your recursive solution, what would you do is that you would actually populate 1, 2, 3, 4, 5, 6, 7, 8 as the minimum number of jumps to go to the 6th location, 7th location. It will be n. The value will be the same as the location number, correct?
Yeah.
You would populate the 100th location already as something, and then when it comes time for you to pop out of the recursion stack and then make a final jump, you would have already computed that thing. By using this mechanism, you're using like a depth first option, right? Not a breadth first.
Yeah.
So you will be recording or memorizing the longer value first, and then you will try to get there through a shorter path, and you will ignore it if you don't do it properly. So you need to do memorization with a little bit of more cleverness, in the sense that you will say, I'll memorize it, but I will check if I am able to reach there faster, then I will just use that mechanism, that number. So it's not like just memorization, but you have to be a little smarter with your memorization. Will that help? Anybody else? I think Pramod, I thought you had a solution. You were talking about something.
So my motivation was from your approach. When you have a very large step, and it becomes really difficult after that. So what I did was I started from the end. Okay. So I'll take this example and try to explain it. So the first step. So you start from the point before the last step, because you already know that you can reach the last step. So you start from 1. Okay. So you compute the best way to reach, right? This is in 1 step, correct? So you store that somewhere. Okay. Then you go to the previous step. The best way to reach, or the minimum number of steps it takes to reach from the 1 to the last step is 1 step and then another step. So it's 2 steps, correct? So are you following so far?
Yeah.
And okay, so now you go to the index where 3 is there. So what is the minimum number of steps it takes to reach 4? You can either go 1 step and 1 step and 1 step. Oh no, you can either go 1 step, or take 2 steps and take 1 step, or you can directly jump to the last step. Correct? So the minimum number of steps.
Can I suggest? I understand the algorithm. I understand the approach. This makes sense. Just in the interest of time, I just want to throw in a different spin to this thing, saying, what if you actually start with the end and not the beginning? Okay. Instead of starting from 2 and trying to reach 4, let's start from 4 and try to reach 2. Okay. So let's. From how many cells can you actually jump to 4 in 1 step directly? 2, 3, 1, 1, and 4, right? So so from here I can reach 4 in 1 step, correct? I'm on line 120 for people who are not who are looking at the screen. Correct? From 4 I can reach 4 in 0 steps. That's the answer. From 1 I can reach 4 in 1 step. Correct? How many ways can I? What about this guy? Can I reach 4 in 1 step?
No, you need 2 steps.
Okay. Okay. What about this guy?
1 step.
Yes.
Okay. What about this guy?
X.
Not possible. Not possible. In 1 step I cannot reach 4. Correct?
Yeah.
Okay. If at this point of time, if you had actually found a solution that had, if this had been like a 10, for example, right? Then this would have been 1 and you found the answer. You're good. The minimum number is 1. Okay. So since it was 2, this is 0. This is X, right? Now what you want to do is you want to go through all the elements from the right, essentially. Try to see how many ways can you reach this location now. Can I reach from here? Right? Can I reach from here? Yes?
Why is it 2? Why is it 2 there?
No. Can I reach one from here? I can, right?
Yeah.
Second, this is the second iteration. But between this and this, I can reach a destination one jump here. Why should I waste my time going? So I'll leave it as 1.
Okay.
Can I jump from here to that location? That location I cannot.
Yeah.
Okay. Now
in the second iteration, shouldn't that the last element be 1 jump instead of 2?
this element,
Yeah.
it is 1 more than what is the value here. Since you are trying to disambiguate this person, whatever this value is, we are trying to get there, right? So it will be 1 plus whatever is there.
Okay.
So so this is 2. This is also 2 for that reason. But then since this value is already 1, I would take the minimum of that, and that's why it's 1, right?
Okay.
Now I'm trying to. Now I'm going to just disambiguate this. Then the next thing I'm going to disambiguate. I'm just going to keep going left. Okay. What about this guy? I can go from here. That's 3, but since 3 and 1, it's actually 1, and then this is 3. Okay. That's a solution at this point of time. And this guy makes it 2. Does that work?
Okay, so 2 is the answer to reach to 4, right?
Yeah. Yeah. This actually optimizes on storage because you'll only store one value, one extra value corresponding to every element of the array, and the value that you're storing is essentially it's just a number of jumps that you need to take from here to the end goal. That's it. The shortest way to get to the end goal.
Can you explain?
Some of them. Go on.
Can you explain the 3? I didn't understand why 3 is sitting there in 122.
Because till we calculated, till we came to this 123, right? We were only trying to figure out how can you get to 1. We solved for this. We solved for 4. Like how many ways can you get to 4? Like what are the shortest? Then we solved for the next guy.
1B is on that. Okay.
Correct. Then we solved for this one, which is 122. We solved for only this 2. How many ways to get to that? Then we are solving for how many ways to get to 3. So till you solve for that, you didn't get to the 2 solution.
Okay. If you want to reach to say 1000, right? You still need to calculate all from 1 to 1000, right? Or not?
You don't have to calculate from 1 to 1000. You actually, if you had, like for example, if you had like bunch of zeros, right? Like this, for whatever reason, okay? And imagine the numbers were large enough to cover for that in the past.
No, like let's take the example of like the first step, like you want to reach to 100, and the first step is 100, and the rest of the steps are 1, 1, 1, 1, 1.
Okay.
How would this sell?
If it's all this, right? Something like this, right? So then the way this will work is that in the first iteration, you will know this will be 1. Everything else will be x, and this will also be x, because let's say this was like so large, not 1000, but let's say it's like 10. Okay, so it's more than 10, right? So this is how it will be the first time.
Yeah.
Okay.
Everything else will also be x.
Everything is x except the first one.
Yeah.
Right. And then after that, this will be 2. Everything is x. Then this will be 3. Everything is x. This will be 4. This will be 5.
Okay.
And this will be 5 as well, or something like that.
Okay.
And you have the solution.
Okay.
Let us say that it was actually there's 1 more in front of this, right? So that's not like it's not an answer yet. So this will be 5.
Yeah.
Then you'll do 6, 7, 8, 9, 10, 11 and whatnot. and then finally this will be the solution, where it will be like this will remain 5 and this will become 6.
Take a small jump and then.
Right. It depends on the solution, but all right. So we are pushing against the clock here. So I wanted to take a couple of minutes to just close it out. So number one is thank you for joining this call, and I think I had fun walking through these problems. I am planning to have the next one next week, and I'm planning to actually start with coding questions, because I think we've been doing DP for the last 2 weeks, and we haven't done much of coding. So I want to make sure that we do coding, and I will not have design question for at least another couple of weeks, and we'll come back to design in a while. So if you have any questions, suggestions, or anything, send me an email. Please do spread the word, talk to others, we get this going. Folks who are in Seattle, local to Seattle, there is a session which is happening in the Seattle, in the Bellevue Public Library this Saturday. The Seattle Tech Interviews meetup group actually runs it. It's a pretty nice session. Folks who are local, don't miss it. Eugene is running it. It's a problem-solving workshop, and we plan to run a session every week, so that's another forum for you to participate in. If there's any questions, any concerns, any suggestions at all, please send me an email. My email address is on the top of this. It's vivek@sdeskills.com, and looking forward to seeing you guys next week.
Sure. Thank you.
Thank you.
Thank you.
All right.
Thanks.
Awesome. Bye-bye.
Bye-bye.
Bye.